Welcome back, friends of the Jörn channel. Mr. Michael Schiebel behind the camera and myself are very happy to welcome you again. Today we're going to create a new format. That format is called Secrets of Jörn. We will have some different topics. One will be development. So I will talk about the development secrets of Jörn. Another one would be innovation. I will talk about the innovation process and innovation itself at Jörn. So if you don't want to miss any of these very, very fascinating topics, please don't forget to subscribe to this channel. Okay? Good. Today I will talk about development secrets of Jörn. So enjoy the video, have fun, see you later. Okie doke, let's get started. Development. What is it about? What do we want? What is what we would like to receive from our customers, from you? Well, honestly speaking, you will never satisfy us. There's one option is you get us involved at a stage where you have already defined all the boundary conditions like stiffness, forces and loads, how to connect, package space and all this stuff. Of course, if you present all this detailed data to us, we will answer to you, well, thank you very much for getting us involved in these very nice projects, and we're very happy to help you. However, it would be great if you could get us involved next time at a very early stage of the project. Then we're going to have more chances to influence all the stuff towards a very, very competitive, cost-effective and great rubber metal part. Well, so next time you call us and said, well, Jörn, please come and join our new project. We don't know anything. We have not yet defined the stiffness we need. We have not yet defined the forces. We don't know the loads. We don't know the package. But we know that we have two components which we want to connect by a rubber metal part. So in that case, we would say, thank you very much for getting us involved in this very nice project, and we are very happy to help you. But it would be great if you could define a little bit more detail, technical detail, because where should we start? So in other words, you will never satisfy us, you will never make us very happy. However, asking me, I would say I prefer the second option. So where it's going to start from a white piece of paper. So, I mean, that's development, right? At an early stage, you have many degrees of freedom, but you must make a point. You must just let's fix something and let's start from here to there, and then let's analyze the situation. Okay? Doing that, you get first ideas, first information, and for the next step, it's not that wide, it's a little bit smaller on both sides. So if you continue doing that, the shape of that looks like a funnel. And at the end of the funnel, of course, a very nice rubber metal part will be the result, more or less automatically. Okay, a little bit more work needs to be done, of course. Let's get serious. At the beginning, you do lots of simulation work. I mean, that's great, and that's very important to do so. However, rubber metal parts are not that easy to simulate. They have so many non-linearities in the characteristic of the material behavior, such as it's non-linear in terms of amplitude, it's non-linear in terms of temperature change, as well as frequency, you know? So it's very difficult to get to consider all these different aspects in a simulation model. However, it's the best thing to do when you have nothing. Right? So do the multi-body simulation, get an idea about the frequency behavior of the subsystem, or of the system and our subsystem, our part. I mean, in a higher frequency range where noise and acoustics will come to the table, the prediction of rubber metal parts is difficult anyway. However, if you have nothing, that's the best you have. So get started, make the first point from where you start to further improve your system. The thing with rubber metal parts is it's a rather small component, but however, in the full environment of your machine, of your car, of your vehicle, of whatever it's going to be, it is a component which is connecting larger components. And the behavior or the characteristic of a rubber metal part, like stiffness, damping and so, is influencing significantly the vibration behavior of the whole system. So a small part has big impact. Well, that's it. It's a very important part influencing the noise, the vibration and the harshness, or as the expert says, the NVH. So you've done some multi-body simulation, so you get an idea about the vibration behavior and other things such as comfort behavior and so forth. And you build a first prototype. So do we. But I mean, if you're not very clear about the detailed requirements, I mean, it's not best idea to build a tool. A good idea would be to take a part which is in your production portfolio anyway, with similar characteristic to what you've simulated in your model. And maybe with some minor mechanical changes to the part, such as drilling or machining a little bit on the rubber sheet or so, you can change and modify the characteristic, the properties of the part towards the ones you want to have. Okay, but by doing that, you have rather simply produced a part which is near to the behavior of what you want, and it's something you can test at the beginning to validate your model. So once you're a little bit clearer about the detailed specification of our part, we will check in our database whether we have parts with similar characteristics. Because if you have a part with similar characteristic and you just need to modify it a bit, I mean, it's just by applying similarity methodology, you can easily predict very precisely the characteristic of a part which is very similar to one you already know very well. Okay, so that's a very good. That's the best way to get a new part. However, sometimes it's not possible. Sometimes you don't have a similar part. Then, of course, you start doing some sketches. You start doing some rough calculations. Let me say you do some educated guess of the parts, and of course we have some supporting tools to do all these calculations, to do these educated guesses. These are Jörn developed calculation tools to get a good idea about the characteristic, about the stiffness of the parts. Once you have done these simulation, these calculation, you start doing a detailed 3D CAD model, which can be used for FEA calculation. And here again, you do it stepwise. I mean, in the first step, you do it with a linear FEA calculation, but sooner or later you have to change and upgrade the model to a nonlinear calculation because the material properties are significantly nonlinear. After the FEA, you have a good idea about the stiffness curve, the stiffness characteristic. Next step you want to know is the durability. What is the fatigue behavior of your part? Well, there are some fatigue simulation tools in the market which are very, very complicated, very sophisticated tools, and it's a very sophisticated methodology to do so. Again, the tricky behavior of rubber material, the nonlinear behavior, makes it even more difficult. So the results of lifetime calculation for a rubber metal part are very, let's say, questionable. I mean, what we have is we have some values, some limits for the tension level in the part, and as long as we are below that, lower than these comparison values, than these numbers, we know from our experience that we are going to be okay. I mean, a very important guideline for you if you start doing your own design with first layout of a rubber metal part, please consider tension is never a good idea. A rubber metal part will just fail very, very quickly if you apply any tension. So not even for static load, but of course never ever during operation as well. Please don't forget that. That's a very, very important design guideline for rubber parts. After all the theoretical calculation and simulation work, you have a design where you believe from that this could be a potential prototype part. So you have to build a prototype. Building a prototype from rubber metal requires an injection molding form. You can't do it without. 3D printing is not applicable for our parts. You can build a 3D printed part and it will meet the shape of your rubber metal part, but never ever the mechanical characteristics. However, you need to build an injection molding form tool. That takes time, unfortunately. And our rough estimate is, depending on the complexity of the part, it will take between 8 to 14 weeks before you get first prototypes which are meeting your requirements. What do I mean by that? What does it mean? It means that there's one loop of improving the tool is included already. Why? Of course, many simulation methodologies are applied to tool building as well, such as filling simulation of the tool. That's a very important figure to look at for the toolmaker process. Another one is shrinking. How does the rubber shrinks? That's also very important. But beside all these simulations and all the results you get from there, you want to be a little bit more conservative in building a real prototype tool, because if the prototype part would be too small, that means the tool is too small. It's very easy by machining to remove a little bit more material and make it bigger. The other way around, adding material is very much more complicated. So you want to be on a safe side, and that means one design loop is included. So that's part one of development. I mean, I'm very sorry, but I've talked too much. I'm an engineer and I became too enthusiastic talking about engineering and development. I like that, that's my hobby. So please forgive me, but that means most likely we're gonna make two parts of this development topic. So today we want to close part one, and I would say thank you again, Michael Schiebel, for your support behind the camera. Thank you for us. Thank you for watching us. If you like that, please leave us a like, leave us a comment, and just to remind you, don't forget to subscribe to the channel in order not to miss part two and the other videos which will be presented very soon here in this format when I will talk about innovation. Thank you very much for this time and see you again soon. Bye bye.